So we're gonna look at how to make surfaces in both programs or both interfaces. If you open this one here, you can pull that out and see all the surfaces that are available, or the surface construction methods available in Rhinoceros. In Grasshopper, we go to Surface, which is here on top, and we go to Freeform, and we can, if you just click once, you see all the components available. So to compare these, we have, for example, if you hover here, you see surface from 3 or 4 corner points, and we see, here, 4-point surface. So already you see there is actually the same methods in both interfaces. The next one here is surface from planar curves, which is also here, boundary surfaces. They don't have the same name, but they are conceptually exactly the same in the way you construct surfaces. So you see here also the next one in Grasshopper, edge surface. Create a surface from 2, 3 or 4 edge curves. We have the same one here as well. Surface from 2, 3 or 4 edge curves. So remember to always hover and then read both the title and the text below, because then you see what these components actually do. Here, for example, is loft. So create a lofted surface through a set of section curves. You can probably imagine how that is constructed. Loft is also available, of course, in Rhino here to the left. Yeah, so I can demonstrate in both programs here how to use these. So first we have surface from 3 or 4 corner points. If I do this here in Rhino, this is what it looks like. Then again, that was flat, wasn't it? So if, let's say, we have 4 points like this also, and maybe 2 of them go up here in set direction. So you see there you have something like this in 3D space, and then you can simply use these points for your surface. If I have the render mode, it looks something like this. It's actually a doubly curved surface, quite interesting. So I can delete that one, and I go to ghosted mode to see that. And the same procedure can be made here. So if I take 4-point surface and I simply set each and every point here, as you see, you don't need to take out a specific point component from here. You can actually just right-click directly on the input. The disadvantage then is that you cannot select the point that you're working with. What happened now? Well, I selected 3, so that's the least it needs. Then it actually creates a surface like this. This is, of course, flat because all 3-pointed surfaces are flat. That's a natural rule. So if I hover on the D input, you see it's empty. So I set 1 point there as well, and then it's going to be completely different. It's the same kind of doubly curved surface that we had previously. And you know how to do this, so you bake it, and then it becomes an actual geometry. Here one can also actually compare both of them. One is made in Rhino, one is made in Grasshopper. They look very similar indeed, but the thing is that everything you do in Grasshopper is much more exact, actually, because it's calculated mathematically and have exact coordinates. And in Rhino there is the possibility to actually click wrong sometimes, and which can have very big consequences for the surface quality. So there's one of them. We can also check out the surface from planar curve, which is a fairly easy thing. It's simply like this. You draw something Now you see I drew it on the C-plane, so it's completely flat. I can select it and click surface creation, and then you have a flat surface, but that's only for absolutely flat surfaces. The thing we can do here, we can take that into Grasshopper, and we can make surface here, boundary surfaces, and take it in, and you see you have the same sort of surface. Well, yeah, so you can try that out, please. The best thing is that when you draw yourself, you will understand how everything works. If we make a loft surface, we can make, for example, something like this, some kind of strange shapes like this. They're all closed, as you see now, and I draw them on one plane, but of course this doesn't work, so I select two of them and move them in Y direction here. And this is no rules, of course. This is very much like the user wants to do it, depending on the design task, of course. So this is just an example. And if I then hit loft here, loft, and then it asks me up here, select curves to loft, then I click them simply like this, and it asks me something again, flip, or which direction it is. And this is then the surface, the completed surface of all those section curves. And then you can have settings as well. You see, for example, that it bulges, and this is because it's calculated along these NURBS curves, which are all 3-degree curves. So that's why it's bulging. Instead, you can also do like this. You select that again, and we can then go to loft option. You notice perhaps that I just clicked OK before. So you can go here and take it, for example, straight sections, and then you see the appearance is quite different. It simply makes a 1-degree curve from between each of the section curves. So I'll take cancel there. The thing is, we can also make a loft here. So I can take all the curves, and I make and I go to surface, and I go to loft, and the same thing happens. What is weird though is here you see also the much more exact situation in Grasshopper. So I'll take this away. It did not really work, did it? Or is it something else? The thing is, Grasshopper analyzes all the curves very particularly, and it even knows where I started to draw. So you see this red line going here, all the way down here. It goes from start point to start point to start point, or start point, end point, it's the same. And then it actually builds the curve like this. So you see the exactness in Grasshopper in comparison to when I do it in Rhino. Then it simply uses the whole curve as one big segment. And here it actually divides it into different start points and so forth. So what can we do about this? Well, if you hover on the O input, you see one locally defined value, loft. Well, there are settings there. Very much like the settings we saw before, but these are much more particular. So, So here you have, for example, normal, loose, tight. It's the same thing as I showed you before. So if I take straight sections, it becomes straight 1-degree curves between the section curves. But that's not what we wanted now. So the thing is, if you see these aligned sections, here we can use the same thing as what happens in Rhino. That means that they will try to put these endpoints or start points in the same position along the extrusion or the loft operation. So if I click that and take commit changes, it turns into the same shape we had before, actually. So that was the solution to that. And why is that interesting actually? Well, if you don't have it and you start rotating one of the curves, then this seam will actually follow the rotation. This can be very handy when operating, when handling large surfaces or mapping something on it. This is actually crucial to know where this seam is, which we will see later on. So if we continue to other surfaces we can make, we also take this off and I open here again. You see, for example, surface from 2, 3 or 4 edge curves. Then I have to draw some curves, of course. So I do like that and like that, for example, and move that in Y direction and go to perspective mode. Then we can use that one, surface from 2, 3 or 4 edge curves. That means that can build from 2. Is the 2 curves is the least you need. So I just click these and then it builds something in between. So we can go to the next one here, which is then, for example, surface from 2, 3 or 4 edge curves. So then I have to draw curves first here. So for example, like that. Certainly only an example, of course. So if one hovers, it's obvious what you need. The least you need is 2 curves, so you just simply select those and you build a surface between them. And the same thing is available in Grasshopper. I take edge surfaces, and then I'm actually going to take in this. You can actually add it directly here, but then you don't see the curves you've used, so I recommend doing this. So that one and that one, just take them in like this, and then a curve is created. So we can also do something like this. We can continue if you want to have a curve in the other direction. And you saw that I did that now on purpose, a bit strange. So I can do that here as well. Just so you see it can actually move around in space a little bit. We can do like this even to see what happens. Very strange curve indeed, but as I said, only an example, right? So we're gonna make a surface that are constructed from these curves. Then you simply have to add the other ones as well, this one and obviously this one, and take them in, and then it completely changes the surface. Looks like some kind of flying cloth or something like that. This is also something you can do, of course, in Rhino. I just copied that now, and the equal component is this one. I can simply select them all. A fun thing to do, or a very interesting thing to do, is of course to bake both of them and then take a look at them to see if there is any difference at all. You can see something here, that is that the Rhino surface is actually built from more quads than the Grasshopper surface. Yes, so another very interesting thing that you can do here in surface modeling, I'm not going to go through all of them, but just as a first option, which the first options you can make, the very common ones. So another one is sweep, which is this one, sweep 1 and sweep 2. So they are made like this. So I might have a curve going like this. And let's lift that in Rhino here, like this, for example, even more complex. So this is what it looks like in the 3D space. So then you can actually let something flow along this surface. So for example, I do this curve like this. Front view, let's see, something like this. Just want to lift it a little bit to make it even more crazy. And then we can simply go to the sweep component here. I'm not sure if this is, well, it will be quite visible what this is about when you see it. So you click the sweep command, and they ask the program then asks select rail. So it's like a train rail more or less, right? So this is the rail that the train are going to, and then you have cross section curves. So you see it's plural, so it can actually be more curves. So let's try with one first here, so like that, and voila, it's actually made this very strange shape for us. Then of course we can also do something like this, that we alter this by making, let's do a straight curve there, and let's do something like rounded, quite large thing there, just as a test. Of course this is a very crazy shape. Sorry, that was a little bit straight. Let's just do an arc here, like this, for example. I have to draw it in. I have to draw it, of course, in one plane there, so it becomes straight. But creating the curves also an issue, of course. So, but that's a completely different story right now. By the way, if you right-click in the command line, you can take the last things you've used. So sweep one rail is one, this one, and then you simply select these cross-section curves in order, and then it turns into something like this. So then you can. Even though this example was a little bit strange, you can surely understand the benefits of this command and what you can do with it. And this is of course also available in Grasshopper. So I have 4 curves, right, like this. The rail I can have a little bit up here, so I take in the rail. One has to of course remember which one that is. And then you can take the curves, and when you do the rail, by the sweep command, by the way, one has to take them in a specific order, otherwise everything looks quite strange. So sweep 1, this is we're gonna look also at how it is with 2 rails. You can use 2 rails, but this is the first one. So then you take the curves here, take them in, and again you see something's actually a bit weird. It's because Grasshopper is much more exact, so it actually understands the direction of the last curve. So I simply double click and type flip curve, and I see that it is the last one, right, in this case, and then I have to assign all these curves here. So there we go. And again, it's very interesting to bake it to see the difference. In this case, they are very, very similar, aren't they? Yes, it's quite hard to see any difference at all, actually. Yeah, so what's up with the second rail? So I'm just gonna copy this one and put it somewhere like there. Well, and distort it as well. Then I recommend to do this first with, you know, like only one curve, because one section curve, I mean, because that's when actually things are gonna start happening. Because if I have 2 rails, sorry, I'm gonna take this out. So, it will actually transform the section curve along these 2 paths. So if I go to sweep 2, select first rail, click, select second rail, click, select section curves, it will actually then automatically spread that section curve along the rail. But obviously it's not absolutely super good, so in this case I made some very strange curves. So let's take this one again and look how it looks like here. This one, and I'll take the same rail, the second rail, and this one. The same thing happens. It becomes an overlapping here, but it's because of geometrical reasons. I mean, I couldn't have done it in another way actually, but you still see the point I'm trying to make. And then you can experiment with that and try out several different variations with more section curves, and also try to change the curves here in Rhino while you're working. Another option is of course to draw all the curves in Grasshopper itself. And that is of course based on different, for example, you can have different construction points like this. This is usually how I do it. And maybe you have some you have a lot of sliders then of course to make an interesting curve from this. So let's say I do something like that, right? And then I can have an interpolation curve here. It needs more like this, and then we can start seeing something quite soon. So this is the curve I just made. And it's parametrically set, as you see. So I can change it all the time if I want to. Set on 3 curves like this. Which is very handy indeed. This can then be used as a rail, of course. So yes, in that case I would, for example, do something like this, a circle, which is almost like a piping thing going on then. If I take the first point and I take a sweep 1, the rail, and then that's my section curve. I do have a surface already. Of course, now I made a pipe, didn't I? That's also available. So that's another very, very handy thing you can do, like a pipe structure like here. And you add it, wait a minute, take this out. And it pipes something, pipes a curve. And it can pipe 100 curves in the same time. So which is, of course, very handy indeed. So try to... if I, for example, copy this now with a move component and another one, you see I can make pipes from several curves at once. And this is a very perfect surface here actually. So this is the last surface I'm going to show you now. And then there's options as well to make it flat or round in the edges. This is round, for example, or this is flat. Yes, so try to experiment a little bit with the surfaces in Rhino and the surfaces here free form in Grasshopper. Thank you.